Yeah? Wow. That's weird. We'll do it live! Alright, let's go. Alright, so... Hey! Nice. Wow, saved my life. Alright.
Everything's funny further away. It's so weird.
Did someone actually make you a pencil sharpener so you can put it in there?
I was actually. My eyes said go. It's gonna leave. You all suck, right?
Sit down.
My eyes said
Yeah, I think that was thrown in there actually from out there.
Really?
Yeah, I'm not joking.
Wait, should I move it? Otherwise, like, if I...
Sharpening pencil's a good pencil sharpener, back there. Yeah, it's electric.
Yeah, Mr. Mac. Mr. Mac.
It's over by all the other stuff.
There's another producer who walked in here, but what the heck?
I know. That's pretty much what always happens.
See?
Alright.
Can't get stuff.
Down.
He didn't believe me when I got.
Alright, lots to review, not a lot of time to do it. Let's get it done. We are live right now. I'm going to move this in an attempt to straighten it out without having it cut out on me. Alright, so, Geometry Quiz number 5 review. This is the mega quiz. It's got a lot on it. The good news is I think a lot of this is going to come back to you as we go through it, and it won't be that bad. Remember, I give you lots of examples because examples are what the people want, right? So, don't be intimidated. The quiz will be shorter. Also, every question I take off, I spot you points, right? So, it's going to be all right. Right? We give the people what they want. It's not complicated. All right, so, use the diagram for the following proofs. We're going to prove that angle 3 is congruent to angle 15. So, here's 3 and here's 15. Okay? First off, write down what you're given. We are given that line P is parallel to line Q, and we are given that M is parallel to N. So, how are we going to prove 3 and 15 are congruent? You can't just say cap and they are, right? We got to make it there. Whoa, that was pretty cool. So, 3 to 7. How do we know 3 and 7 are congruent? By cap. Angle 3 is congruent to angle 7. I'm going to go quick, guys, so make sure you're ready. Okay, I'm not pausing for you guys to write crap down. We know those are congruent by cap. And then we know that 7 and 15 are congruent by what?
Cap.
By cap again, right? Because they are corresponding, bottom right corner of their intersections. Again, this would not be true if these were not parallel. Again, look. 3 and 7 are congruent by cap because we have 2 parallel lines cut by a transversal, yeah? We know 7 and 15 are also going to be congruent because we have 2 parallel lines cut by a transversal and they're corresponding, right? So 7 and 15 are congruent by corresponding angles postulate. And then the plan is we're going to switch out 7 for 15, right? Because 7 is 15. So now we have 3 and 15 together. What do I call that when I switch stuff out? Substitution. So angle 3 is congruent to angle 15 by subs, which is what they wanted. Swag box. Okay? How do we feel about that? It's a lot to write down. It's hard to keep up, but do you see what's going on here? Okay? Wonderful. 2. Prove that 10 is supplementary to 7. So they're not going to be congruent. Angle 10 we'll do in blue. And 7 is already red. So we need to prove they're supplementary. How are we going to do that?
10 and 11.
Throw them all up here. Don't make any more, Xavier.
I haven't made any.
Wonderful. Coda, stop making them. I want you to not bomb this. That was a really good throw. Coda, throw it. Let's go.
Coda, here, look. See it. Let me see it.
That was horrible.
All right, Aiden, you throw it up here.
Yeah, I got it.
Thank you.
Yeah.
All right, no more. So, angle 10 and angle 7, we're trying to prove them supplementary. How are we going to do it?
10 and 11 are supplementary.
All right, cool. So 10 and 11 are supplementary. Let's start with that. How do we know 10 and 11 are supplementary? So 10 and angle 11 are supplementary. Let's use green. What do we forget to do first? State the givens. Yeah, you are. But I'm going to make it worth a point. That way it's easy and it gets you more points, right? So if you forget it, it's your own fault. So given that, We know they're supplementary by linear pair theorem because they are a linear pair. They're on the same line. They're both on line Q, and they make up 180 degrees, right? So they're supplementary. So now we've shown 10 and 11 are supplementary. What do we know about 11? We're trying to get it to 7.
Capped to 15.
It's corresponding with 15.
Capped.
So we know angle 11 is congruent to angle 15 by corresponding angles postulate.
You're capped.
All right. And we know what about 15 and 7?
They're capped.
They're also capped. So again, here is the logic before I write it down. 10 and 11 are sup. 11 is 15. 15 is 7. Which means 7 and 10 are supplementary, which is what we want, right? So, again, we just showed that 15 is congruent to angle 7 by cap. And now we're going to do two substitutions at once. We haven't really used transitive property in here yet because we've been doing really simple substitutions, but I'm going to use transitive property now. So let me show you. Okay? We know that 15 is the same as 15, so we can switch out 7 for 15. We know that 11 is the same as 15, so we can switch out 15 for 11. Right? So check it out. If 7 is 15 and 15 is 11, then 7 is 11. That's transitive property. We're going to use that in a second. So 10 and 7 are supplementary. So I'm going to write that. 10
I'm writing my entire equation.
and Danny, either get funny or shut up.
I'm just letting you know.
I know, but it wasn't really funny and it was just annoying. All right. So by transitive property.
Yes.
Remember, the transitive property is the one where I'm touching the table's touching the paper, therefore I'm touching the paper, right? So it's just like a triple substitution. It cuts out all the middleman. 7 is 15, 15 is 11, 11, right? So we have 7 is 11. So 10 and 7 by transitive property, and they are supplementary. Sorry, I'm trying to go quickly. 10 and 7 are supplementary by the transitive property. Don't just tell me 10 and 7. Tell me what they are. Okay?
That's my question.
Yes. Yes, you may. It's not in here.
Don't you go quick.
Do you see what's going on here?
Yes.
Smell what I'm stepping in? Awesome. All right. Turn the page. We're on to page 2. Read the instructions. It says given. Measure of angle 7 is 85. So I'm going to find angle 7. I'm going to mark that right now. 85 degrees. Angle 10, they said, is 115. So I'm going to mark that right now. It says find the measure of the given angle and state whether you use vertical angles, linear pair, or corresponding angles postulate to get your answer. Okay? Don't forget to state the reasons. Now, to save on time, to get to the gist, I'm just going to make all my markings on the diagram, and I'm going to say out loud how I got that. Okay? So, if I know angle 10 is 115, I know angle 12 is 115 by what?
LPT.
Vertical angle scissor theorem, right? I'll accept either. Okay? 10 and 14, are they congruent,
Yeah, where's that?
or are they not? Why aren't they, Zayden? They look like they should be. Check it out. If you want to know if 10 and 14 are congruent, first cover up everything you don't need to look at, right? Do we have two parallel lines cut by a transversal? No, they're not parallel, so they're not going to be congruent. What about 10 and 2? Sound like Mr. Bartos, right? 10 and 2. Two parallel lines cut by a transversal, right? So they are going to be congruent. Yeah, I know. So I know that by cap, right? And then I know 2 and 4 are the same by vertical or scissors theorem, right? Let's look at angle 7. Is angle 7 congruent to 15 by cap? It looks like it is, and it is because we have two parallels. W and V are parallel, right? And we have a single transversal, right? So that is also going to be 85 by cap. We get these by vertical. Now what about the other angles? Well, we know 6 and 5 have what relationship? What's their relationship? They're supplementary by linear pair theorem, right? So if 5 is the same thing as 7, it's 85, right? Well, if that's 85, how much is left over for angle 6? 95, because they have to add up to 180. You dig?
Yes. You need.
All right. 6 and 14 will be congruent by cap. Also, you just do linear pair again to figure it out with 13, right? And then vertical or scissors for 16 and 8. Will 16 be congruent to 12? No. And look, they're not. Because we don't have two parallels cut by a transversal. Up here, angle 1 is going to be congruent to angle 3 by vertical. We know that. What is the measure of angle 1? What will the measure of angle 1 be? And how would you figure that out? Aiden. 65, and we know that by linear pair, right? Because 115 plus 65 is 180. Again, you want to do 180 minus 115 in your head? What's 180 minus 100? 80. What's 180 minus 10? I'm sorry, 80 minus 10 is 70. 70 minus 5 is 65. Do it bit by bit. And then we know 9 and 11, too soon, are going to be 65 as well.
Too soon?
Question, comments, concerns other than from mental stability?
You ever watch?
Nope, don't care.
You ever listen
Turn the
to
page.
Chance the Rapper?
11. Find the measure of each angle. Chance the Rapper was the song of the day in here, you dingus. All right.
We didn't hear some today.
Yeah, not today, but it was like a couple weeks ago. Okay, we listened to the same drugs, yeah.
'Cause we did-
All right, so it says find the measure of each angle. So here's what I'm going to do first. I'm going to mark all the angles that are congruent and go from there. Angle 1 is congruent to angle 3 by vertical. Are 1 and 9 going to be congruent by cap? They will, because we have two parallels cut by a transversal. You see it? Awesome. So 1 and 9 are the same. 9 and 11, too soon, are the same by vertical. Will 1 and 5 be congruent?
Yeah, that's true.
Will they? Yes, because these two are parallel, and that's the transversal. So 1 and 5 are also congruent. 5 and 7 are congruent by vertical. What about 5 and 13? Will they be congruent? Yes, they will, because we have two parallels cut by a transversal. So check it out. When we have two sets of parallel lines, everything just works out really nicely. Okay. So what does that tell us about 3y plus 10 and 8y minus 50? What's their relationship? Zayden. They're the same. They equal each other. That means 3y plus 10 equals 8y minus 50, doesn't it? Can we solve for y? Will we get a nice answer for y? Yeah, because we have one equation with one type of variable, right? I'm going to get my y's together by subtracting 3y and adding 50. So I get 60 on this side. I get 5y on that side. Division is divorce. We divide everything by 5 to separate the 5 from the y, and we get y equals 12. We are not done because they did not ask us to solve for y. They asked us to find the measure of each angle. So now that we know that y is 12, let's plug it into this one. What's 3 times 12? 36. Add 10. 46 degrees. How are we going to figure out all the green angles? Linear pair theorem, right? They're sup. So 180 minus 46. Let's do that in our heads. What's 180 minus 40? 140. Subtract 6 more. 134. So all of those leftover angles are 134.
I'm not drawn to scale.
No. Right? Because this one looks like it should be bigger, and it ain't. Crap happens. It's just not drawn to scale. Like, who cares?
Dude, the dang stuff into this.
12. Solve for each variable. Okay, so all we got to do is find x and y. We don't need to plug it back in necessarily, but it might be helpful to plug it back in, right? First off, I have two parallels cut by a transversal. So let's mark all the congruent angles. I know that this angle and this angle are congruent always by vertical, right? Are these two angles here and here going to be congruent by cap? Yes, because we have two parallels cut by a transversal. So this is the same, and this is the same. So that tells us about these two angles. What's the relationship between these two angles? They're the same. Now, we could write 9x plus 12 equals 4y minus 10, but is it going to be helpful? No, because we have two variables here. So while it's a true statement, it's not very helpful, right? What we need to figure out is what's the relationship between 3x and 9x plus 12? Because if we can set those up, we'll be able to solve for x. So 3x is this angle, which should be congruent to this angle by cap, right? And if I write it like that, I think you'll be able to see what is the relationship between 3x and 9x plus 12. They equal 180. They're supplementary, right? They're a linear pair. So if I write that, 9x plus 12 plus 3x equals 180. Again, sometimes they're supplementary, sometimes they add up to 90, sometimes they're congruent, right? You have to figure that out and then set up the proper equation. Now I've got 9x and 3, which makes 12x. We subtract 12 from both sides. We get 12x equals 168. And if we divide by 12, we get 14. Trust me on that, okay? Cool? So x is 14. Now we need to find y. How are we going to do that? Yeah, go ahead, Alicia.
Solve for x first.
We found x.
Well, like, put it into the.
Yeah. So I'm going to put it into this one because, one, that's easy to do. Easier than this, right? Also, I know those are supplementary, right? So if I do 3 times 14, that's going to be 42. Life, the universe, and everything. Any Douglas Adams fans in here?
Of course not.
Hitchhiker's Guide to the Galaxy? No? Okay. I once read that book in my sophomore year as like a creative reading class type of deal. You get to pick your own book. And I didn't realize the one I checked out from the library was missing like this many pages, like that thick of the book. And I just kept reading. It was no big deal. My book report was very strange. Later read it in life and was like, oh my gosh, this is great. Other book didn't make any sense. All right, so reading comprehension. These two angles are going to add up to what? 180 because they're a linear pair. So now I have something that's useful here. 4y minus 10 plus 42 is going to equal 180. And I can solve for y now because there's only one variable in this equation. So when I do the math, I get 4y on one side. That's 32. I'm going to subtract it from here. I'm going to get 148. Divide by 4. 100 divided by 4 is 25. 40 divided by 4 is 10. So that's 35 put together. 8 divided by 4 is 2. So that's going to be 10, 30, 35 plus 2, 37.
37.
So y is 37. Questions? Comments? Concerns? Other than for my mental stability?
Nah, I'm not really concerned about that.
Just so we get this for posterity. Shout out to Aiden for dressing as me for Halloween.
Yes. I have another costume. I'll come in here and show you.
Please do.
Yeah, it's Bugs Bunny.
Bugs Bunny?
Yeah. For Space Jam.
That's dope.
Yeah. Very small.
13, solve for each variable. So here's what we're going to do. Let's extend the parallels so we can see what's going on a little bit better, right? Like, yeah, this is a trapezoid, but we don't care about that. What we want to look for is transversals. No yawning in math class. Maroon, mauve, burgundy, chartreuse.
Chartreuse?
And if I extend that out, I think we can tell that this angle here is going to be the same as that angle here. And these two are the same by vertical, right? Same thing here. Do you see it?
Can you see it now, Mr. Adams?
So I think it might help if I write this as 3x. Or you could write this as 5x minus 20, whatever, right? What does that tell us the relationship is between 3x and 5x minus 20? They're the same, right, by vertical. So that means I can do 5x minus 20 equals 3x. They do not sum to 180. They're the same thing, right? They're not a linear pair. And this is not only a true statement, but it is helpful because we have one variable for one equation. I'm going to get my x's together. Terrible idea in real life, great idea in math. We get 2x over here, and I'm going to add the 20 over, so I get a positive 20. And when I divide by 2, I get x equals 10. Now I'm going to go and plug that in. That way I know this is 30 degrees. These are congruent, so they better be 30, both of them. And if you check the math, it's 50 minus 20. It is, right? Now, what kind of shape is that?
A triangle.
A triangle. And triangles are called triangles because
They have 3 angles.
they have 3 angles. And the 3 angles always sum to 180. So we know that 2y plus 4y plus 30 is 180. If I write that out, it's a true statement. Will it be a useful statement? 2y plus 4y plus 30 equals 180. Will that be enough to help us solve for y? Yeah, because we have one kind of variable, right? So I know that 2y plus 4y plus 30 equals 180. That means 6y equals 150, and y is going to equal 25. How do you feel? Yeah?
Danny, are you fair?
14, this is the weird one where you have to draw like a auxiliary line, that's what they call it. So what I'm going to do is I'm going to draw that in right here at the intersection of that weird angle thing. Is it good, Katie? Is it a good straight line? Wow. October 31st, 2019. Katie drew a straight line. All right, so what that does is it divides up x into a top part and a bottom part. So we know that the red and the blue together is going to be all of x, right? Cool. So we're going to find the blue and the red individually and then add them up, and that's going to get us x. So if you notice, this angle right here is the same as this angle right there by cap, right? We have a transversal and two parallel lines. So this right here and this right here are the same by vertical, which means this is 62, which means this is 62. Cool. Might help to extend this out. These two angles are vertical, aren't they? If I extend that out, so they're the same. This angle and this angle are the same angle by cap.
Yes, sir.
How much is the red angle?
Yes, sir. It's one.
36. How'd you figure it out?
I subtracted 144.
These two angles are supplementary. So that's 36, which means this is 36, which means x altogether would be 98, like the boy band from the 90s. 98 degrees. Another way to do it is to say, look, 144 and this angle are the same. So 144 minus 62 is going to get you what's left over here, yada, 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 right? But I like my way the best. Turn the page. What is slope? What is slope?
No idea. Y equals mxb plus b, but that's slope-intercept.
That's slope-intercept form. That's an equation. What is slope?
The
Yeah. The rise over the run. So slope is m because parlez-vous français. It is the rise
what?
over the run. Okay. What's another way to think of rise over run?
Up over down.
Change in y over the change of x, which is the same thing as this. Can't really see it or can't see it?
Up or down, right and left.
Check it out. So Alicia's right. Rise over run is the change in the y, change over the x, right? This guy right here represents the change in x, otherwise known as the distance, horizontally, right? How much we changed horizontally, the run. So I'm going to tell what that is by saying that's horizontal distance. Why do we know it's distance that it's talking about? How do we know that represents distance? Distance is subtraction, right? How do we know it's horizontal? Because x, right? It's the x distance, the horizontal distance. So the top part is going to be vertical distance, right? Because it's the y's in subtraction. That's it. Again, if you know that it's the rise over the run, you know rise means how much we change vertically. Well, it's how much we traveled vertically. Distance, vertical distance. What is vertical distance? Distance is subtraction. Vertical is the y's. Ah, it's the y's being subtracted from each other. I don't have this memorized. I know that it's rise over run, and I know what that means, right? I would encourage you to know what it means. Change is delta, right? Ready for 16?
I guess.
All right, we're not going to do all these. I just like to give you lots of examples. Okay, they give you two lines, and the way they give you the lines is they give you 2 points that are on the line. And we want to tell whether they're parallel, perpendicular, or askew. Remember, askew just means that they intersect at some random angle, right? Because if they're not parallel, they're going to intersect at some point, right? So either we have really cool intersection, perpendicular, right?
How long is this test gonna take?
No intersection, parallel, or we have random intersection, askew, right? So when lines are parallel, the slopes are what?
Same.
The same. When they're perpendicular, the slopes are,
Intersecting at 90 degrees.
well, that's true.
Opposite.
But the slopes are going to be opposite reciprocals, right? Flip and negate. And askew is just they don't equal each other and they're not that, right? So it's neither, right? When it's neither of those things, they're askew. Okay, so how do we find the slope between 2 points? Well, we just did it on the last page, right? We wrote what slope is. It's the change in y over the change in x. So here's y between those 2 points. How much did we change? If we started at -2 and we went to -1, how did we change in what direction? +1, right? We went up 1.
Askew.
0 to -2. We went down 2, right? Or really left, because we're talking run. So our slope could either be written like that, or like that, or like this. All those are the same, right? So there's our slope 1.
M1.
Yeah, M sub 1, not MF.
Mother.
There's another Bill O'Reilly quote. MFer, I need some iced tea. All right,
Say it.
I did. So,
You gotta say it more enthusiastic.
nah, I'm good. So these two, -3 going to -4, I went down 1, right? -1 going to -3, I went down 2. Which means our slope here is going to be 1 over 2. Look familiar? It's the homework, literally. I did not change the numbers on this one. Are these slopes parallel? No, they're close, but they're different. They have a minus sign here, not a minus sign there, so don't screw that up. Okay? So not parallel. Are they opposite reciprocals? Well, they're opposite because they're opposite signs. Are they reciprocals? Nah, they ain't flipped. So it's neither, which means they are askew.
Edmund Devon.
Who asked you?
There's actually a guy at the last name back. He's a very good basketball player.
Gotcha. You feel like you could do those? Okay, cool. Again, you're not sure, use the formula, plug it in, minuses, right? Just don't miss your double negatives. Or just think, how much did I travel? That's what slope is, right? Think about it, think about it. 21, it says we want to write the slope-intercept form of the equation of the line described, then graph it. So, they want a line that's parallel to this guy and goes through this point. So if we want a line that's parallel to the one that was given to us, that equation for that line is going to have the same what? Same slope. So we know it's going to look like this, right? With some b value. There's a line that's parallel to that. Then we want the line to go through -4, 6. What does it mean for a line to go through a point? It means that that point is a solution to the equation. Meaning that when we plug in -4 for x, we should get 6 for y. Right? That's the equation we're looking for. So what does b have to be so that when we plug in -4 for x and 6 for y, that happens, right? Well, in order to figure that out, we can plug this in and find out what b has to be. How do we do multiplication with fractions? Well, we're allowed to times by the top or divide by the bottom. We have to do both, right? But we can do it in either order. Would you rather times by the top or divide by the bottom first? I'd rather divide by the bottom. What's -4 divided by 4? -1 times the top is
Oh, it's a
-3.
-4.
You could have also times by the top. 3 times -4 is -12. Then divide by 4, -3, same thing. Add 3 by the addition property of equality, and we find that b has to be 9 if x is -4 and y is 6. So that means our equation that we're looking for, the parallel line, is going to be y equals 3/4 x, that way it's parallel, and the y-intercept will be at 9. And that's the equation that both is parallel to the one they gave us and goes through the point -4, 6. Because when you plug in -4, 6 pops out. Now we're going to graph that. It's in slope-intercept form. So the intercept's right there. That's one free point, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have an intercept at 9. And we just need 2 points to make the line, right? How are we going to get our other point?
Up 3 over 4.
Use the slope, right? If you start out on the line and you use the slope, you're going to end up on the line again, right? So I'm going to go up 3 over 4, 1, 2, 3, 4, and put a point. Could we have also gone down 3, back 4?
Yep.
We could. And then you're going to make your line. Just for funsies, did we screw this up? Well, one way to check is to graph the original line. And the original line is -5 for the y-intercept. Again, the black line is not part of the instructions. I'm just doing this to show you. If I go up 3 over 4, down 3, back 4, these lines look parallel. Does our blue line go through the point -4, 6? Yes, it does. It's right there. So we did it. We made it parallel. And it goes through the correct point. How you feel? Do you need to include that black line? No.
All
Look at number 23. If you don't know what it means, this is a hard problem. If you do know what it means, it's super easy, which means I'm going to include it because I want to give you free points. But inevitably, you're not going to know what's going on, and you're going to be like, this is impossible, right? So make sure you think about what it means. We want a line that's parallel to x equals 5. So maybe we should graph x equals 5 to see what that is, right? X equals 5 is this. 1, 2, 3, 4, 5. That's where x equals 5. But remember, we want a line, so we want all the points where x equals 5. So 5, 1, 5, 2, 5, -1, all those points are where x equals 5, right? So what kind of line is that? Vertical. So that's the line x equals 5. If we want a line that's parallel to that, the other line has to also be vertical, doesn't it? Okay. Well, they want it to go through -7, 6. That's here. 1, 2, 3, 4, 5, 6, 7, up 6. 1, 2, 3, 4, 5, 6. So that's -7, 6. They want it to go through that and be parallel. Well, I can draw that, right? Now the question is, what is the equation of that line? It doesn't have slope, right, because it's undefined. So we're not going to get a y equals mx plus b. What do all of those points have in common? X equals -7. As soon as I know it has to be vertical, I can just look at that and be like, oh, look, x has to be -7.
That's all you do.
Yep. That's the equation of that line. It's parallel and goes through that point, right? Do you see what it means and how to go about thinking about that? Okay? If I give that to a calc student, they're going to be like, what? Right? Because they don't actually understand this crap. Because they've never had me as a teacher and they've never been forced to learn this, right? All they know is y equals mx plus b, m is the slope, b is the y-intercept, blah, blah, blah. Follow the steps, right? You guys know what it means. So this should not stump you. Look at number 24. At least I think number 24. Let me flip the page. Yes, look at 24. Parallel to y equals -2. Well, first of all, what is y equals -2? Well, here's where y equals -2 on the y-axis, right? We want all the points where y is -2. Well, 1, -2, 2, -2, 3, -2, all have y for -2. What kind of a line is that?
Straight.
All lines are straight. Horizontal. So if we want it parallel, our other line also has to be parallel, right? Or it has to be horizontal. We want it to go through the point -1, -8. So we want it to go through that point. Okay, well, pull out your protractor. What is the equation of that line? All those points have something in common. What is it?
Y equals -8.
All the y values will be -8, right? So the equation that's parallel to that and goes through -1, -8 is going to be y equals -8. Smell them stepping in.
Yes.
Yo.
Okay. Look at 25. We want an equation that's perpendicular, which means the slope is going to be flipped and negated, right? So our equation for a perpendicular line is going to be -1/3 flip. What happens when you flip a third? 3/1, which is 3. Change the sign to make it positive, right? So the equation here is going to have 3x plus b. And to figure out the y-intercept, we plug in our points. What does b have to be? That way when we plug in 5 for x, we get -2 for y, right? That's what we're asking. As it turns out, b has to be -17. So our equation is going to be y equals 3x minus 17. Now, how do you graph something like that? We don't have the ability to go down to -17. Yeah.
Actually, never mind. I was gonna say divided by 3. It's not like that.
Can't. Yeah.
Yep.
Can't do that. What?
Use the point.
5, -2 is on it, right? 1, 2, 3, 4, 5 down 2, right? That's on that line. That's what we did, right? What's our slope? 3. So we can go up 3/1 from there, and that should be our line, right? If I extended that out, eventually it would cross the y-axis at -17. Be clever. Think. So here's the line. Just for funsies, let's graph the original equation. They give us y equals -1/3 x plus 6. Here's 6. 1, 2, 3, 4, 5, 6. -1/3 means down 1/3. And if I keep doing that, I'll have my line. And look, they do hit each other at what looks like 90 degrees. If you graph both of these to check your work and they don't hit each other, you probably goofed, right? Ta-da! Never chase after a bus. Questions? Comments? Concerns? Turn the page. Look at number 27. Y equals 6. What kind of a line is that going to be? Horizontal. All of the points where y is 6. You dig? So here's where y equals 6. 1, 2, 3, 4, 5, 6. Here's all the points where y equals 6. 1, 6, 2, 6, 3, 6, 4, 6. Red 6, bluefish, something. We want one that's perpendicular. If it's perpendicular, is it going to also be horizontal? No! It's going to be vertical, right? They want it to go through 0, 0. Here's 0, 0. So here's the line that goes through 0, 0 and is perpendicular to that. Now the question is, what is the equation? This guy is y equals 6. What do all the points on this red line have in common? Think before you answer.
X equals 0.
X equals 0. 0, 1 is there, 0, 2 is there, 0, 3 is there. So the line that is perpendicular to y equals 6 and goes through 0, 0 is the line x equals 0. All the points where x is 0. How you like them apples?
I don't like
Makes
this.
sense.
Turn the page. Here we go. The rest are all the same thing. It says find the slope of the equation of the given line, then find perpendicular slope to the given line. Then find the equation of the perpendicular line, it goes to the given point. Graph that line. So, in other words, find the slope of the line they gave you. It's just what we were doing, except they didn't give you the equation, right? You have to find the slope yourself. How are we going to find the slope of that line?
Pick 2 points.
Pick 2 points, 2 nice ones. I'm going to choose there and there. Looks like we go to the right 3. That's a positive direction, right? and I went up 3, which is also positive. So my slope is 3 over 3, which means our original line has a slope of 1. You dig?
You do. I do.
So now we know the slope is 1. We want a line that's perpendicular to that, which means our perpendicular slope is going to be what? Negative 1, because we flip it and negate it. 1 flipped is still 1, right? And then we negate it. We want it to go through that point. So we could do the y equals negative x plus b thing and then plug in whatever that point is and figure it out. Or we could do it graphically. Let's use our slope. Down 1 to the right 1. Again, it's perpendicular, right? That looks perpendicular to me. Now, where does that line cross the y-axis? 1, 2, 3, 4. Negative 4. So the equation of the perpendicular line is going to be y equals negative x minus 4. Could you have done it this way? Y equals negative x plus b, and then plugged in this point. That point is negative 4 comma 0. Could you have plugged that in and solved for b? Yes, you could have. It's what we just did, right? So if you're not sure about this, or it's like a weird number, right? It looks like it crosses it maybe 2/3 of the way down or something, right? Plug it in and do the algebra. It's way easier, right? This one needs to be perpendicular. Done. What's the equation of the red line? It's all the points where y equals negative 2. What's the slope of the original line? Zayden. The slope.
Oh, the slope of the original line
Mm-hmm.
is
Undefined. The directions say find the equation and the slope of the original line. So let's go back to the first one. Y equals regular x. The y-intercept for the original is at negative 3. Do you see that? Make sure you do all the directions. I'm sorry, I forgot about that. Zayden is right for the next one. X equals 2 would be the original line, right? It's all the points where x equals 2. How do you feel? It's a lot, but I don't think it's like crazy hard.
Oh, it's not very artistic.
Do not take this lightly. I'm throwing you a floater, so knock it out of the park. Okay, but the floater's still a dangerous pitch, right? It struck up that one guy. You ever seen Rookie of the Year? Right, they get the guy, the Mets guy's like super big. He's supposed to be like Mike Piazza. He's so angry, right? You get the kid who broke his arm, and now he's got to throw the fastball a million miles per hour. But then his arm breaks again. He can't do it. He's got to get this guy out. He's the only guy that's ever able to hit him. So he learns that his dad wasn't the spoiler. He learns that his dad wasn't the superstar baseball player because his dad like left him or something, right? And he's like, oh, I'm good because my dad's good. No, it was his mom who was an amazing softball player, and she's like, he floats it because he can't throw a fastball anymore. His arm's broken, right? So he can't do anything, so he floats it. And Mike Piazza swings and a miss, right? And they win the World Series. Actually, no, they don't. They win the pennant, and then they go on to win the World Series. But still, right? And that's the first time the Cubs won the World Series before they actually got to win the World Series back in 2016. Yeah. So, love that movie growing up. Rookie of the Year. Look it up. It's great. Fantastic film. Quiz tomorrow. Destroy it. No mercy. Take no prisoners. What? I know. But they did.
Try and fly this thing. It's literally impossible. That one works decent.
Yeah, I figured. It's
horrible.
It's a trick plane.
It's a trick horrible.
Oh, yes! 2 days in a row.
It's a trick plane.
That's actually kind of
Go away. Everyone go away.
The other
Nelly,
one.
did you get worse? Wait, did you guys just like trade? Is this like a Freaky Friday thing? Alright.
Look at this one. This one looks sick.
You're right.
This one looks
It
sick.
does look sick.
And it's pretty good. It's pretty decent.